Hello everyone. I'm Monica from Cybersecurity Center of Excellence. I welcome you all to the very first session of CCoE Cyber Startup Showcase series on OT and IoT security. Today with us, we have the team of Analysabl, who are experts in OT and IoT security space. We have with us Mr. Vasu Adunutula, founder and CEO of Analysabl Private Limited. Mr. Vasu has proven experience of establishing and leading large engineering teams to deliver complex projects. In his 25 plus years of experience in the IT industry, he established the R&D Center for NCR in Hyderabad and has led its growth to a 1,600-member organization. As a technology leader, Mr. Vasu has focused on product development, product management, and professional services in financial self-service and engineering domains. I now welcome Mr. Vasu to give a brief introduction. Over to you, Mr. Vasu.
Thank you, Monica. I'm really excited to be here in the initial first session of the Cybersecurity COE series. The topic we are going to talk about today is regarding OT and IoT security. OT security is about how the cybersecurity needs for an industry. How do we ensure that the assets that we have in an industry are secured and that we are ensuring that the equipment, the different control systems that we have in an industry are protected against cyber attacks. We also are going to talk about what is IoT security and the growing importance of ensuring OT and IoT security cannot be understated. There is an increasing number of attacks happening in both these areas, and we'll have Venu heads up cybersecurity practice in Analysabl, and Venu is going to walk us through some very rich material on what is OT security, what is IoT security, and what do we need to do to ensure that we are safe against these attacks, and what are the solutions, what is the problem statement, and what are the solutions which are available to handle this. With that very brief introduction, I'll hand it over to Venu to walk through and start touching upon the topics for the webinar today.
Thank you, Mr. Vasu. Thank you, Mr. Vasu, for the brief. Moving on, we have Mr. Venugopal Narasimhan, a seasoned cybersecurity specialist with extensive knowledge in network security, cloud security, and OT IoT security. Mr. Venu has worked with global majors, advising them on the right cybersecurity solutions to implement for the organization from a pre-sales and a delivery perspective. Across his career, he has led large engineering and pre-sales teams working with organizations in banking, telecom, manufacturing, and utility industries. Mr. Venu is a co-founder of Analysabl, where he focuses on building best-in-class consulting and product teams to cater to OT and IoT security solutions. I now welcome Mr. Venu to take over the session. Over to you, Mr. Venu.
Thank you. Good afternoon, ladies and gentlemen. I hope you can hear me loud and clear.
Yes, we can hear you well.
Yes.
Thank you. So what I'd like to do is I'd like to briefly talk about cybersecurity in general over the next 45 minutes or so. Focus a bit on OT security, why it is important, and why that is seems to be an area where organizations are investing in when it comes to cybersecurity. Then I'll touch upon IoT. Right, I'd like to classify OT and IoT as two different aspects, while there are a lot of commonalities. I'll talk about industrial OT, and then I'll also talk about smart sensor kind of the IoT devices, smart homes, smart cars, or whatever, and what challenges do you typically tend to see in these areas. So that's how I've divided my session. And what I'll do now is quickly share my screen so I can walk you through the material that I had prepared. Can you all see my presentation?
Yes, we can.
Okay, thank you. So this is what I wanted to do. Like Vasu mentioned earlier, talk a bit about OT security, the challenges. We'll look at some case studies, what kind of hacks have happened in the OT space. We'll also look at potential ways in which we could reduce the attack surface when it comes to OT security. So that's one aspect of what I'd like to do. Subsequently, we'll talk on similar lines when it comes to IoT as well. But before I get to that, why is cybersecurity important? So a few years ago, not too long ago, 5-6 years ago, if you were to go to an organization and talk to them about cybersecurity, it would be the last of their priorities. Right? People had other priorities when it came to IT, and cybersecurity really was the last of their priorities. Given the fact that people have experienced what has happened worldwide over the past 2-3 years, when most of us have to work from home, and the amount of increase in the attacks that have happened, I believe this, along with the need for compliance, has increased the need for investing in cybersecurity. People are beginning to see the need for ensuring security when it comes to not just their IT infrastructure, but also their OT infrastructure and IoT infrastructure. To put things in perspective, this is an average day in an enterprise organization, right? So this is data that I got from the internet. So this is not our data, but this is freely available data. What you see here is, on an average globally, every 24 seconds, you have somebody accessing a malicious website, not knowing it is a malicious website. Right? Every minute, there is a bot that is sitting somewhere in a network that is doing a recon of the network and communicating with the command and control center back. Every 34 seconds, an unknown malware is downloaded. So what do we mean by unknown malware? It means that it is a very, very new version of the malware that the world has not seen. So it is a malware that is 0-day, if I could use that word, which does not have any signatures so far. And because it does not have signatures, nobody has a solution for it. So you could put an antivirus there, but then the antivirus would not be able to identify this as a malware because the antivirus does not have a signature of this particular malware. So every 34 seconds, something like this is happening. Subsequently, you see that every 5 minutes, somebody is accessing a high-risk application. What is a high-risk application? Applications that are vulnerable, that are risky, right? All of us tend to use AnyDesk, all of us tend to use TeamViewer. There are a whole bunch of applications that we used on a day-to-day basis, right? Remote control of a different desktop, right? RDP protocol on regular basis. All these are classified as high-risk applications because there could be ways and means in which somebody could get into an organization. Subsequently, every 6 minutes, you know that there's a virus that is being downloaded somewhere. And from a data privacy and data security point of view, every 35 minutes, there is some sort of sensitive data that is leaving the organization. So look at the challenges that a CIO or a CISO would face in order to ensure compliance, in order to ensure safety as well, and making sure that the day-to-day activities go on without any challenges. So this really is the challenge that is constantly hitting organizations around the world on a very, very regular basis. So I'll switch to OT specific attacks. I can always talk about examples of IT attacks, but OT attacks, since we're talking about OT, I'll talk really about OT attacks here. It started as early as 2014. Of course, I have a use case which I'll talk about in detail after these slides, which will show you that OT attacks have been there for about 10-11 years now. 2014 December, there was a German steel mill that was hacked. The mechanism that was used was spear phishing. What does spear phishing mean? You're essentially opening a mail from somebody whom you think you know, right? So somebody is impersonating somebody you know, and then trying to send a mail to you on their behalf. And then you typically tend to see the name. You say, okay, I know this person, and then you open the mail, and then it launches an attack internally in your east-west traffic in your network. So that's one. December 2014. That's how the German steel mill was hacked, and apparently it was one of those hacks that actually damaged hardware in the factory. Right? It went and apparently, a boiler was destroyed. There's a big use case about this on the internet. 2015, there was this attack on Western Ukraine where somebody brought down the power systems, right, in Ukraine. The funny thing is these power systems were actually providing in Ukraine, which means that people were in their houses at minus 40 degrees Celsius and they could not use the heating system because somebody brought it down. Right? So you could look at various kind of attacks here. You've got put in those for treating the water itself. You have some more attacks here. NotPetya ransomware was a big attack that again hit Ukraine, brought down a lot of organizations around the world. And of course, a lot of organizations in India were affected as well from an OT point of view. Likewise, the most common one of late is the colonial pipeline. The colonial pipeline was something that has been in the news for about a year now. And this was again remote desktop protocol vulnerabilities that were exploited. People ran a phishing campaign and then got that down. So, and of course, the Oldsmar water treatment plant was something also that happened, where people tried to change the amount of lime that is being added to the water, and this water is going to the city's water distribution system. So, look at these attacks, right? They are somehow, going away from just enterprise IT systems to at some point somewhere affecting human life as well to a large extent. So this is what the attacks are happening. Now, why is it happening? If you look at why this is happening, why such attacks are happening over a period of time, you should just go back in history and look at how cybersecurity attacks have evolved over a period of time. So the late 80s, people had the concept of virus. Right? You had these floppy disks that people used to use. You had viruses that were invented, and this was just done.
Yeah. So Venu, we are not able to, view your slides. I think there's some issue. Can you just stop and share it again?
Okay. Can you see it now?
Yes, we can.
Oh, okay. Thanks. Please let me know, because I'm not sure why this is happening. But yeah, if you're still not able to see it, just let me. So if you look at the evolution of how cybersecurity or cyber attacks have happened over a period of time, one of the things is that it started off in the late 80s. Right? It was more mischief. When a couple of Pakistani brothers decided that they want to invent something called virus that will just cause some disruption. All they wanted to do was have some fun at somebody else's expense. How the industry evolved is that the industry said, okay, there is this virus, now we'll have to find a solution for this. And that's how antivirus as a technology was born, right? Late 80s. If you look subsequently in the early 90s, when the internet was born in its commercial form, right, and mass and used in mass, widely used, that's when network-based attacks started increasing. So people found a way in which to go and attack technologies that were evolving, technologies that were new in the market, and they wanted to find ways in which they could penetrate that and go and cause some sort of trouble. So when network-based attacks over the internet started, firewall as a technology was born, right? Companies came up with firewalls to be able to prevent these attacks or at least defend against such attacks. Subsequently, early 2000s, what happened? People started, attacking applications, because a lot of applications were being built. People were using applications in their landscape. People had access to internet, etc. Now, in order to stop such attacks, the concept of intrusion prevention systems and intrusion detection systems were born. But then you see this constant battle. Somebody is trying to attack you always, and then you're coming up with the technology to defend. So this has been happening since the 80s. It's not something that is new, right? And the late 2000s, you look at it, people started using payload-based attacks, which means sending you links via email, and these links would be infected links. There could be a picture or an image, and these would be infected images. There could be an Excel document which had malware embedded in it. So different ways in which payload was being sent as a part of a phishing campaign that would potentially then cause an attack. And then you had the concept of mobile-based attacks that were starting up as well at that point in time. So again, how the industry reacted was to build something known as a sandbox technology, right? So sandboxing as a technology came into play in the cybersecurity industry when payloads were actually the cause of problems, and people had to payload, explore it in a sandbox, try to understand what is happening. All this had to be done in real time. So the sandboxing is the technology you want. Now, what has happened is that it's now moved subsequently further, right? What you see SCADA-based systems, industrial control systems, systems that are SCADA systems. These are systems on which attacks have happened significantly now. And this is clearly industrial IoT and IoT. Attacks on these are happening. And how is the industry evolving? We have got to a stage where we have been able to identify what are the potential challenges that organizations have in securing industrial control systems. Because industrial control systems are not as regularly updated as a Windows server or as a Windows operating system or in that sort, and anything, a Mac or whatever. Right? So you do not want to update operating systems or software running on machines because those productions have to be running 24/7. Your production line has to be running 24/7. So people tend to leave things as it is. Legacy systems remain in place in SCADA, and people do not want to change that. So the evolution of attacks have happened over a period of time. At every single point in time, wrong people are always one step ahead. The industry has always been one step behind, catching up and fighting, right? And it's also because that while an organization might have 100 separate doors to protect, all a wrong guy wants is one door open. He does not need those 100 doors open. While you have to guard those 100 doors, people just need that one single door to get into your organization. So this has been this constant cat and mouse battle that we are seeing in the cybersecurity industry. And it's got to now the industrial control systems or OT, operational technology, or IoT based attacks as well. So who are these attackers, right? What the question people always have is what do you enjoy by attacking or causing harm to somebody else, right? But then this is a professional industry today, right? It's actually a professional.
Venu, your voice is cutting out every once in a while. Venu, are you there?
I'm trying again. I don't know why. I'm trying. Yeah.
Yeah. Share your screen.
Can you all hear me? I have to reshare. I'm not sure what this is.
Yes, I can hear you.
Okay. And can you see the screen yet?
Not yet. Yes, I can see it now.
Okay. So sorry about that. I'm not sure what happened in between. So what we're talking about is who are these attackers, right? I was talking about who these attackers are. Ransomware as an industry has grown, right? So you can actually pay people for ransomware attacks, and then based on the amount of ransom that you get, you could actually do a profit sharing with the hacker. So that's the way the industry is evolved. So it's a professionally run business right now. If you look at the hacking industry, a little bit of examples of who these people are, right? One, there are state-based actors, right? Countries attacking countries. You see that in the news. You hear that in the news all the time. You have a particular country attacking a different country. Then there are, of course, people who are a part of the organization, but then they are not happy with the organization. They want to do some mischief while they are leaving the organization. To give you an example, the Maruchi County Service. The Maruchi County Service was an attack where an employee was leaving the corporation of that particular county in the US, And while or rather he was fired, one of those things happened. And while he was leaving, he decided that he's going to launch an attack, and he started releasing sewage water into the particular state or in that county, right, through an attack. Next is teenagers, right? People who just want to have fun at somebody else's cost. This is again the Lord's Tram option that came, or rather the attack that happened in Poland. The Lord's Tram attack in Poland was a teenager just buying some local devices, and then IoT devices, changing the tracks of the tram in this particular location, and then this went and then caused 2 or 3 trams to crash. Right. So this was again just a teenager trying out things with it. And then of course there are activists, Greens activists who think that big corporations are responsible for a lot of environmental pollution, and they should somehow be punished because the governments are not punishing them. So these green activists are a group of people who tend to launch attacks as well. So there are multiple such actors who are launching attacks everywhere. Then, of course, you have individuals, right? You have individual professional hackers who are also part of these groups as well. So let's look at how an attack happens. Right? Typically, if you look at an anatomy of an attack, there are various stages. Intrusion happens, a person does not automatically look and subsequently make a launch into an or an attack as such. So there is something called as a dark web. So people are going to go to the dark web, do some research and about the company they want to attack, because usernames to launch an intrusion space. So and if you look at the industrial control systems or OT operation technology, manufacturing.
Venu, I think we're still having a challenge with your audio.
What you're seeing today is that organizations are moving towards IT and OT convergence, which means to have IT systems connected to OT systems.
Hello, Venu.
Hello.
We
Can you hear me?
Yeah, your voice is now clear.
Okay, I'm not sure why. This is because I'm on a good Wi-Fi bandwidth. So sorry about that. I think I would assume the screen share is gone as well.
Yeah.
Yes.
I'm not sure why. Sorry, guys. So I was talking about the type of attacks that happen. Right? You have people who are doing homework before an actual attack happens. So there is the intrusion stage, and then there is the attack stage, the eventual attack itself. So people get from a laptop in the IT world right down to a PLC in the OT world, right? And that's how attacks in the OT space happen. But then there are various other reasons, and I'll talk about those reasons in the subsequent slides. One example of an attack is Stuxnet, right? Stuxnet is widely considered as one of the first attacks in cyberspace. It's widely called as the first World War in cyberspace. And this was apparently a worm that was launched to ensure that Iran's nuclear program at that point in time was disbanded, or at least slowed down, if not completely stopped. So this is what happened with Stuxnet. What happened is that somebody ensured that a worm was loaded onto a USB drive, and this USB drive was plugged into a laptop in the OT network, and subsequently there was a worm or a piece of malware that went from the IT network or from the USB drive right through to the infrastructure and then got down their infrastructure. So while it did not actually stop the nuclear program, it pushed it back by many years. And interestingly, how did this happen? Stuxnet actually exploited vulnerabilities in Windows, right? And at least 4 of them were zero-day vulnerabilities. What this means is that even Microsoft did not know they were zero-day, they were vulnerabilities. Somebody found these vulnerabilities that even Microsoft did not know in a case like this, right? So they found these vulnerabilities, and then subsequently, when this was found, the CVEs were published on these vulnerabilities. So somebody found this, somebody was able to launch an attack. And if you look at how the actual attack happened, all they had to do was infect one particular server, and this server was acting as the machine that is going to do a mass infection itself. So whenever there was a call that is happening from a client to this particular server, it was launching this attack. So this is how the Stuxnet-based attack happened. Why are these attacks possible, right? I'm pausing here, sorry. Can you still hear me better?
Yeah, we can hear you.
Okay. So why are these attacks actually happening? One, because OT systems tend to be legacy systems. You have a lot of Windows XP systems, Windows 7 systems in plants, right, on shop floors. People don't change that. Most of them sit with default configuration, which means that people do not want to change anything. They want to keep things as it is, right? They want to just retain the default configuration because, again, it's about production. It's about production loss. So people want to be very, very careful. Organizations want to do that. Nobody updates patches, whether it is patches of the PLCs or whether it's patches of the Windows itself. Right? And there is zero encryption, more or less. Data is not encrypted. Desktops are not encrypted. So there is absolutely no encryption. A lot of organizations don't have policies and procedures. What if an attack happens, right? What is the business continuity plan to be put in place? There is no such things in place. People don't have traditional things like antivirus running on your endpoints. And then networks typically have to be segmented well to ensure that attacks are limited or attacks are quarantined if and when they happen. These don't exist in the OT space. Sadly, this is one more issue that exists. What are the attack vectors? So if you look at the typical attack vectors that get to the OT, these are the attack vectors. One, people tend to use a lot of USBs. USBs should not be used in industrial control systems, simply because USBs are not safe. Or have a mechanism in which you sanitize those USBs, then use them. Organizations. Second, opening up emails, checking emails in your OT systems are also a problem. Right? This is not something that should be done. Then, of course, there are remote technicians who connect to machines remotely to check about these machines itself. And then there are software vulnerabilities that exist all the time. You have networks that people tend to connect to, and then, of course, insider threats. So these are the attack vectors that typically exist in an operational technology network. And this is the biggest problem. These are areas that typically have to be secured, or have policies and procedures in place that will tell you what to do in each of for each of these attack vectors. Right? So these look straightforward, right? But these are ways in which somebody is trying to get into an organization. So this is a little bit about the challenges that exist typically in the OT network and ways in which people get into organizations here. And if you look at a survey, a recent survey here that Gartner did, priority of organizations is cyber physical systems and IoT security going forward. More and more people are looking at cyber security for OT and IoT. I believe that a lot of investments for organizations would be in this space as well. So this is a priority. And the challenge is that IT is not prepared for this, because IT traditionally is great with ERP systems, is great with vulnerability management, with firewalling, network security, endpoint security, all that we are used to on a day-to-day basis when we work in organizations. Right? So, but IT does not know about OT, unfortunately, simply because in an OT environment, the protocols are completely different. In IT, you know that it's either TCP/IP or UDP. it's either this or that to a large extent, right? HTTP, HTTPS, that's about it. But if you look at SCADA systems, there are close to 2,000 protocols, right? Which tool would be able to really secure or be able to work with all these 1,800, 2,000 protocols, right? So that's a huge challenge. And IT does not know it, right? IT does not know the assets that exist in a shop floor because IT does not go to the shop floor. So these are challenges that typically exist. And that's why IT is not prepared for this challenge when it comes to OT. And what are the challenges that they have to look at, right? If you look at the current situation when it comes to industrial cybersecurity, what you see is that you have a lot of assets. When I mean assets, I mean OT assets, machines, IoT assets, sensors, actuators, etc. Right? All of them communicating with proprietary protocols, like I told you briefly earlier. Right? And there are new methods of communications that are emerging on a regular basis. And OT traditionally was built on the concept of what was called the Purdue model, where there was a model that was defined for you, which said where you need to have your IT systems, where you need to have your OT systems, where do you need to have your historians, machines that connect between IT and PLCs, etc. Right? So there is a Purdue model that is defined for OT, and organizations were traditionally following that when they set up plants. Now that is going because everybody is coming with their own version of the Purdue model because that they believe is better for them. So what is lacking and what is required now is visibility into these assets, right? People still maintain asset information on Excel sheets in organizations. So you have Excel which runs into thousands and thousands of rows which have asset information. People still maintain that, whereas there are tools that will automate the whole process for you. And then you have assets that could potentially be existing right from the scratch if you had built it greenfield, and then if you have a brownfield project that you're executing, you already had some assets, you bring in new assets. So it changes the whole conception when it comes to how you want to secure your organization, because you've got assets that were there, you've got new assets, and all this asset information somewhere is missing, right? How do you really secure in a situation like this? Likewise, very, very limited understanding of typical risks that OT environments have, right? So this is a big problem. How do we understand what kind of risks is it in OT, and how do you secure these risks? This is a problem. Prioritize them, you have to document them. A lot of remote control or remote access, these things have to be secured and recorded. There are ways in which you can do that. So this is some of the challenges that IT faces when it comes to securing OT itself. And now people are talking of the zero trust framework, which means organizations are moving towards an absolute zero trust framework, which means do not trust anybody and ensure that every single check is in place before somebody connects to your network itself. There are still opportunistic attacks, ransomwares. We spoke about a couple of use cases. All it needs is for a malware to go into your organization through a USB, and then from there you could launch ransomware attacks or any sort of lateral attacks in your entire infrastructure itself. So you've got states attacking states. With all the war that is happening now, I'm sure that people hackers in Ukraine are trying to bring down Russian infrastructure and vice versa. That happens all the time, with war or without war. Unfortunately, that's how it is. So how do you identify such threats that exist in your organization? How do you identify what is the software that is running, and do these software have certain vulnerabilities, right? Can you do some sort of threat hunting, a process which says what are specific threats an organization would have? So threat hunting is a mechanism in which you would in advance look for chatter on the dark web to understand if people are talking about your organization. Typically, it is like intel work, right? You're doing intelligence, you're trying to find intelligence about people who might launch an attack against you. So these are ways and means in which people are looking at securing or enhancing or being one step ahead of attacks itself. And of course, subsequently, with the advent of Industry 4.0 and now people talking about Industry 5.0, there is bound to be some stage where man and machine are going to talk to each other, and machine are going to talk to each other. So what kind of processes you have, what kind of security you want to have in a place, to get your organization to that journey. So these are certain requirements that organizations are working towards looking at fulfilling, and that's one of the challenges that exist today as well. So what are the attack vectors in ICS? Right? I'll come back just purely back to OT itself. If I look at OT, what are the typical attack vectors? You have removable media that should not be in a plant, right? Now, unfortunately, people have to use removable media in a plant because you have a lot of information that is being exchanged across your control rooms in the plant. So have a good endpoint data protection in place, not just an antivirus, right? An antivirus will find known malware, but then we saw data which says every 35 seconds or something on those lines, there is an unknown malware downloaded. So have an endpoint detection and response systems in place, right? Spear phishing attacks happen all the time. The biggest attacks across the world that have made headlines in the OT space have been spear phishing based attacks. So have the option to actually do some sort of sandboxing on the data that you get before you're eventually passing the data to the end user. So have some sort of sandboxing technology in place. Most of the sandboxing technology also come with ransomware. So not necessarily you need to have a separate anti-ransomware look. You don't have to look for separate anti-ransomware. You can have ransomware as a part of sandboxing technologies. When it comes to remote technicians connecting to your infrastructure, right? So always ensure that the session is recorded, you have multi-factor authentication in place, and then you allow only the exact time that a technician needs for a particular issue. And then ensure that you continue to patch your software vulnerabilities with IDS and IPS all the time. And of course, having a firewall, doing segmentation between IT and OT is a must. Right? So these are certain best practices. I'll talk a little bit more about them. So this is just, again, the Purdue model I spoke about, right? So you have the various levels, right from the field device, the sensors, the controllers, the HMIs, and then eventually the control network where you have all the IT part of it setting. We'll need technologies that are able to not just analyze all the OT traffic, but also secure them, right? So it's only going to take a few minutes for somebody to get to this level, right? If I'm an attacker, if I'm able to penetrate through this level, through your IT, and given that it is all connected, it's only going to take me a very, very little time to get to the lowest level, which is this field device, and then start changing something here. Change the temperature, change the pressure, right? So something that could cause harm. So ensure that these things are controlled. Have some sort of real-time visibility into what your network is doing. Like you have an IT. IT to a large extent is covered. Do something similar for OT as well. There are specific tools. There are technologies that are able to do that for you. And then ensure that your legacy systems are patched, whether it is a Windows operating system, whether it is an operating system that is running your PLCs. Right? So ensure it's patched. It does not happen. I know it's not easy because people are afraid that a downtime could cause problems for their manufacturing and for their production, right? And they are answerable not just to their bosses, because most of the time these organizations are listed on the stock exchange. They're answerable to their shareholders as well. So there are plenty of people that they have to answer if there's a problem. But then there is the issue. People do issue notices that say, advisories that say, please go and patch what you're running, right? And it just does not happen. These are certain examples. Siemens have given it. Schneider, think of it. ABB, Yokogawa, you think of the organization that manufactures these PLCs that are the heart of an organization from a manufacturing point of view. All of them issue advisories. 90%, 95% of the organizations do not patch it today, right? It's just purely because of that scare us of what if something happens. So patching has to happen, right? And if I look at what are the risks, right? If I look at a typical OT infrastructure, I would have what is known as an engineering workstation. I would have something known as an operator workstation, right? So this is where the human is connecting to the machine, right? It's a laptop or a desktop that is connected to your PLCs, right? To your sensors and actuators. What happens in a case like this? There could be various threats here. Somebody could modify the logic. Somebody could delete the logic. Somebody could just plug in a malware from the USB drive, and then it would go all the way, right? Or it could just be a ruffled employee who does not like what is happening. He just has to do something, connect to the internet, download something, and then walk away from that. Right? So the threats surface for engineering laptop or engineering workstation is mentioned here. The USB, when it comes to an attack surface called USB, then you have the option malware, ransomware, or you just take some production information from your organization and then leak it to the press or competition or whatever. And then you have people accessing the network in an unauthorized way, right? So oversight-based attacks, layer 2 attacks, layer 3 attacks. So these are things that could happen. One of the things that are most commonly used in plants is file shares, right? Because people are sharing a lot of information. So you just go to your C drive, right-click share, and then you share your entire root folder. The problem here is people do not restrict the number of people who can connect to your file share, right? You just allow it as max. This is a problem in the OT space, and this has been misused a lot of times when hacks have happened. So net, you can see the risks when it comes to operational technology exist not just from the outside, but also from the inside. And from the insider threat is not always intentional. There is also configuration issues, lack of information, lack of insight, lack of training that would cause this, right? Because people who are typically working on the plant and shop floors, they are not IT people, right? They are OT people, they are engineering people. So their focus is not security. Their focus is not IT. Their focus is to keep the plant running. So two completely different mindsets that have to somehow work together. And what's the way forward? We believe if an organization wants to look at OT security, they'll have to follow these, right? You try to prevent as much as possible by having segmentation, by having a firewall that can do deep packet inspection of your SCADA protocols. There are firewalls today. Have endpoint detection in place, and then ensure that there is secure remote connectivity. So you're doing all you can to prevent, and God forbid, if this does not work, you have to have mechanisms to detect, which means is there some anomalous behavior in the infrastructure that I can detect? Right? Is there a tool that will help me to do that? Can I do threat hunting? Visibility on all the assets that I have, start, etc. Right? And ensuring that all of this information, while today in the IT world goes to a SOC, we need to somehow get the OT world to also get all this information to a SOC so that it can all be centrally monitored. So on a high level, this is the business or solution blueprint that we should look at from a best practices point of view. So again, if I were to recap this before I go to the IoT space, if I were to recap this, I'm looking at operational discipline, right? Having tools, ensuring that passwords that they have in the plants are not basic passwords that could be guessed easily. I've actually been to a plant where people had a post-it note of the username and password stuck on the desktop simply because they would forget it, right? So, I mean, all it needed was for me to take a picture of that. But then, you know how easy it is, right? So, ensure that you have the latest technologies in place that will help you do virtual patching, that will help you do, a robust firewall configuration, etc. And then restrict access to ports. Ensure that if you have removable media, you always sanitize the drives before you insert them into the removable media, etc. Right? Have a VPN in place for connectivity. Don't allow remote connectivity without it being recorded or without a multi-factor authentication. And more importantly, ensure that your OT teams are also trained on what the risks are when it comes to OT cybersecurity. Right? These would be some basic do's and don'ts when it comes to what people have to do. So there are the people, there are the processes, and then you have technology. Right? So we spoke about technology earlier, what are the best practices. But then people have to be trained. People have to be told, what they have to do. So it's just that people are the weakest link in any organization. So that's a little bit about OT security. I'll briefly, I've still got 15 minutes. I don't need that much, but I'll briefly talk about IoT security as well. So we spoke about OT security, where you have machines, really old machines in a power plant, in an automotive industry. When it comes to IoT, It's a slightly more different. It is all the smart car, smart homes, smart buildings, whatever. So there is a slight difference, and this brings in a bigger challenge because this is again some data from the internet about how many connected devices would be there just a couple of years from now. Now there is also a study which says about 25% of all cyber attacks in 2025 would be on IoT devices. Right? So people are looking at new technologies and are going to look at how they could harm those new technologies, and this is happening as well in the IoT world. And the challenges here are significant because you have a diverse set of sensors, diverse set of products, each of them having their own operating system. Each of them having very, very limited space to even run something as basic as encryption or having certificates implemented on them. So let alone having its endpoint security product implemented, you can't do basic security functions as well, like encryption or certification, etc. Right? So there are huge challenges. How would you have one product that is going to actually secure your entire IoT? It's just practically not possible. How can I secure a car, smart car, which will have completely different protocols, completely different mechanics, whereas vis-a-vis, let's say, a smart home, which would be something completely different. So IoT brings in, it's a monster in itself. It brings in a completely different challenges when it comes to security. So these are the problems that IoT comes into play. And organizations are trying to solve this because IoT devices have to be installed on an edge gateway, right? So can we actually have software that runs on the edge gateway and then secure your IoT devices? So these are things that the cybersecurity industry is looking at right now. Of course, there are tools and products for IoT, but then they are limited to certain areas. You will not have an IoT solution that is perhaps going to secure an Arduino. You might have something specific for CCTV cameras. You might not have something for cars, right? So having something common across the IoT spectra is very, very difficult, and that's certain challenges. Now, again, these are some known IoT attacks. So while the world is talking about 2025 and then 25% of cyber attacks happening on IoT devices in 2025, you already see certain attacks here. And in the interest of time, I will not go into each of these attacks. But just to give you examples, you could just look this up on Google anytime, and you'll see how attacks are happened, right? There was an attack a few years ago that happened in the US that happened through an air conditioner, right? And there was a hack in a casino, which actually happened through a fish tank. Right? So all they want is for somebody to have a sensor somewhere, somebody to have an IP somewhere, and then they're able to break through and then do what they have inside. So these are some known attacks in the IoT security space itself. And if you look at the potential attack surface of IoT, it is massive, right? It really is big. You could hijack communications. You could do a man-in-the-middle attack. You have a lot of IoT devices, sensors, actuators, come with firmware issues. The firmware is not strong enough. How do you strengthen the firmware? All the data that is coming from sensors, where do you store it? How do you secure that itself? Can somebody steal the data in the air while the data is being transferred? So you look at the amount of potential IoT-based attack scenarios, these are big. So how do we actually secure each and every IoT device in a scenario? It's really close to impossible. And that's where a lot of efforts from a research point of view, from a product development point of view in the cybersecurity industry is also going in towards IoT. So what I just wanted to explain is a little bit about the OT-based attacks, what are typical attack vectors, and then a little bit about the IoT attacks and what are the typical attack vectors that exist in the IoT space itself. So, which brings me to the end. So, Vasu, if you would like to take over and then say a few words, we could do that, and then I can take some questions.
Sure. Thanks, Venu. Can you move to the next slide?
Yeah.
Yeah, so thanks, Venu, for walking us through OT and IoT. So everyone on the call, so very briefly about what we do as Analysabl. We are incubated startup with the Cybersecurity Center of Excellence. Our focus is on the OT, IoT security space. We talk to customers, understand what their current infrastructure is, help them identify what assets they have. One of the things we realize as we speak to a lot of customers is that a lot of customers do not have a good inventory of all the assets they have within the organization. So they need help to even understand that they have so many engineering workstations, so many PLCs, so many SCADA systems. So understanding that and ensuring that they have a first good inventory, educating them about what vulnerabilities exist within those systems, and then understanding their overall, defining an OT roadmap for them and defining an OT IT convergence roadmap. That's a big part of what we do. In terms of IoT security, we have partnerships with companies which are specializing in specific areas. As Venu mentioned, IoT is a very, very broad area. So we have partnerships with specific companies who have solutions for doing a vulnerability assessment for CCTV cameras. So how do you know that a CCTV camera is not hacked? Doing a vulnerability assessment and then understanding that is very important. So there are specific point solutions for IoT security, which we work on. And then we do that assessment and tell our customers that this is what you need to do to be secure. We do implementation and support. There are some customers who ask for managed services. We do that. And then in specific cases, we do training. We do specific cybersecurity training around OT and IoT security, around cyber forensics. Right. So I think that gives a brief idea about what we are. And Harshad, if there are any questions, we'll be glad to take them.
So yeah, so guys, if you have any questions, please do put in the Q&A box so that Venu and Vasu can take it. They can give their opinion regards to some topics. There's a question from Vikram. Is there any regulatory standard you follow, regularly or in your organization?
Okay, I can take that. Can you hear me? I hope you can all still hear me.
Yeah.
Okay, so there are a couple of regulatory standards when it comes to OT, right? One is the IEC 62443. That's a standard that mentions how OT networks have to be secured and then connected. And then there is something known as the NIST framework. So these are two frameworks, the regulatory frameworks that are there in place specifically for OT itself.
Okay, thank you. Thank you. So any other question? Okay, so I hope you guys have. Yeah, there's one more. Okay. So this Vikram, I will just discuss this with the team and we'll get back to you regards to the presentation. Yeah. So I hope you were really attentive. You understood everything. So I'm going to share my screen, which has our QR codes for our LinkedIn page. So please do follow, so that you can. 1 minute. You can get notifications for multiple events we are doing in the coming days.
Thank you, Mr. Venu and Mr. Vasu, for sharing such insightful information with us on different aspects of OT and IoT security. We have similar interesting sessions lined up in the coming weeks. To know more and to be updated, please do follow us on our social media channels. On screen, you can find our QR codes and links to our social media handles. Please do follow us to know more.
Thank you. It's been our pleasure, Monica. Looking forward to the future session.